Lesson 2.6 is on geometric proofs. So we're going to continue writing more proofs. We're just going to use or tie in some more geometry. We said before that when we're writing a proof, it's important to justify each of our steps with a reason. And we can use symbols and abbreviations, but we must make sure that our work is clear enough so that anyone who reads the proof can understand it. We need other people to be able to interpret our work. When you have a proof, we have our givens, which is our hypothesis, and we have what we're trying to prove, which is the conclusion. To get to that point, we're going to use our definitions, postulates, properties, and theorems. In example A, we're just going to practice writing the justifications for each step that they have shown here. So if I were just writing my justifications, where angle A and angle B are supplementary, and the measure of angle A is 45 degrees, similar to our proof, that is just our given information. Now you can see from step 1 to step 2, they go from saying that angle A and B are supplementary to saying that the measure of angle A plus the measure of angle B must equal 180. We know that's because of the supplementary. And so the reason is going to be the definition of supplementary angles. And we're going to abbreviate it, and a lot of times this is how you will see it. Definition of supplementary angles. So that is how it is shorthanded. Now, I'm looking from step 2 to step 3, comparing, and I see, well, the thing that changes is instead of saying angle A, they are now saying 45 degrees. So what have we done? We have made a substitution. And finally, why can I say that from step 3 to step 4, the measure of angle B is 135 degrees? Well, we can see that we would have subtracted the 45 degrees from both sides. And so we are using the subtraction property of equality. Down below, it says that a theorem is a statement that you can prove. And once you've proven it, you can use that theorem in later in your proofs. So one of the first theorems that they introduced to us is called the linear pair theorem, also sometimes called the supplements theorem. If two angles form a linear pair, then they are what? Well, if they form a linear pair, we had talked before that straight line, meaning 180, they are going to have to be supplementary. Congruent supplements theorem says if two angles are supplementary to the same angle, then the two angles are blank. Supplementary to the same angle. What does that mean? Well, if I had angle A was the supplement to angle B, and angle C was also a supplement to angle B, what would be true about angle A and angle C? They would have to have the same measure, right? They would have to be congruent. Similar to our algebraic proofs, we're going to begin our geometric proofs with the givens. And when we write our geometric proofs, we are going to use a two-column format. So we're going to take a look at example B at proving the congruent supplements theorem. We're going to read our givens. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. we know that our givens should be our first step. So I'm going to go ahead and copy those down, and I might even shorthand a little bit. It's important that after you write them down, you actually take a moment to kind of process that. Angle 1 and angle 2 are supplementary. What does that mean? 2 and 3 are supplementary. We also maybe want to take a look at what we're trying to prove. I'm trying to prove that angle 1 must be congruent to angle 3. As I look at my steps here, my statements, going from 1 to 2, does it make sense that angle 1 and angle 2 are supplementary? Then we can say, well, that would mean that their measures add to 180. Similarly, if 2 and 3 are supplementary, their measures add to 180. Again, by saying they equal 180, that is the definition of supplementary angles. I'm going to go ahead and show you step 3. If 1 and 2 equal 180, 2 and 3 equal 180, they both equal 180 degrees, which also means they can both, or they would equal each other. So my step 3 is going to look like this. The measure of angle 1 plus the measure of angle 2 would equal the measure of angle 2 plus the measure of angle 3. How is that true? Well, instead of saying that 1 plus 2 equals 180, I in fact substituted the 2 plus 3 information. And now, because I know I'm trying to show angle 1 is congruent to angle 3, in my step 4, I'm actually going to make a subtraction. If I subtract angle 2 from both sides, it drops off. So I'm left with the fact that measure of angle 1 equals the measure of angle 3. How did we get that? We used the subtraction property of equality. And lastly, if my two angles have the same measure, then angle 1 must be congruent to angle 3. Having the same measure, meaning they're congruent, is the definition of congruent angles. And again, my last statement here should match up here what I am trying to prove. I should always end with that. Down below, my right angle congruence theorem says all right angles are congruent. We know that if angle A equaled 90 and angle B equaled 90, that angle A would have to be congruent to angle B. They have the same measure. Likewise, the congruent complements theorem, if two angles are complementary to the same angle, then the two angles are blank. Well, if angle A was the complement of angle B, and angle C was a complement of angle B, what's true about angle A and angle C? They would have to be congruent. Taking a look at example C, we're going to practice another proof. In this case, we are given that angle 1 and angle 2 are supplementary, and angle 1 is congruent to angle 3. I'm trying to prove that an angle 3 and angle 2 would have to be supplementary. And I've actually listed out the statements. I just want to practice giving the reasons or the justifications. We know our starting is our given, our true statements. And our proof should flow top to bottom. So we can't just jump to like number 4 and put a reason in. We want to work from the top to the bottom. It should be connected. Our number 2, if we go from saying that they're supplementary to saying that their measures add to 180, that would be the definition of supplementary angles. Now, my step number 3, the measure of angle 1 equals the measure of angle 3. It doesn't really look like it comes from step 2, so I'm going to jump up 1. And I see, well, one of my givens was that they were congruent. If angle 1 and angle 3 are congruent, then they have the same measure. That would be, by the definition, of congruent angles, or sometimes just stated as the definition of congruence. Now I can see in step 4, the measure of angle 3 plus the measure of angle 2 is 180 degrees. Remember, we're working top to bottom. So if I look at step 2 to step 4, what happened? Well, instead of saying angle 1, we're now saying angle 3. We, in fact, made a substitution. If my measures add to 180, can we say they are supplementary? Yes. Why can we say that? That is the definition of supplementary angles. Let's try one more. Example B says that angle 1 and angle 2 are complementary, angle 2 and angle 3 are complementary. I'm trying to prove that angle 1 must be congruent to angle 3. So I'm going to go ahead and set up my two-column proof. Now I'm working off of my given. If it tells me that they're complementary, I know that means they add to 90. So that is what my statement 2 is going to say. Their measures, measure 1 plus angle of measure 2, should equal 90. Likewise, the measure of angle 2 plus the measure of angle 3 should equal 90. I can put those on the same line, and that is the definition of complementary angles. Step number 3. Well, if 1 plus 2 equals 90, 2 plus 3 equals 90. If they both equal 90, I can also say they will equal each other. So the measure of angle 1 plus the measure of angle 2 could equal the measure of angle 2 plus the measure of angle 3. Why is that true? Well, we are making a substitution. Instead of saying 90 here, I'm substituting in my new information. Step number 4, well, I can see that I have the measure of angle 2 on both sides. And so if, again, I use some subtraction, those will drop off, and we'll have left with the measure of angle 1 equaling the measure of angle 3. How did I get to that point? We subtracted. And so, does that prove that angle 1 is congruent to angle 3? Yes, it does. If they have the same measure, they must be congruent. And again, that is the definition of congruent angles, or just simply the definition of congruence. If you'd like to see more examples, you can see the videos that are provided by our textbook company. If you have more questions on this, please stop in and see me.